Now, earlier in the program, we told you about a local tech company that's developing a new kind of cast, which is an alternative to the traditional plaster cast used to heal broken bones. Well, PolyUnity has been using 3D printer technology to create all kinds of healthcare products, from the most basic items used in a lab to more complex cancer care.
PolyUnity was founded by 3 medical students, one including myself, out of Memorial University back in 2018. We had a vision to bring the power of 3D printing to healthcare and wanted to grow that straight from Newfoundland and Labrador. The idea was quite simple at the time. It was to teleport medical equipment. We know that there's rural places all over the province, and we had done rotations into these towns, and things look different when you get over the overpass sometimes. And we wanted to think about a way that we could use advanced technologies like 3D printing to solve problems out in the periphery. At the time, just a little bit of background, is NASA 3D printed something in space. So they had a problem on the International Space Station. They contacted their engineering team on the ground. They designed something and sent it up there. They printed it and fixed the issue. And we thought, why couldn't you do that in Newfoundland and Labrador? It's remote. We have geographical constraints, adverse weather, complicated populations, and if you can do it in space, you could do it to St. Anthony or Labrador or anything like that. So that was the original idea. This is a story that keeps evolving because the technology is changing at such a dramatic pace. I think a good explanation of this is going back to the original 3D printer that I bought. This one was purchased around 2013 or 2014, and this is about as good as you could get from a desktop 3D printer. This was a little finger splint that I kind of managed to pull off, and that took about 12 hours to print, and it was nerve-wracking because it could have failed at any point. But you had to have a bit of a vision to imagine that it could go from this scale and this type of application to the breadth of things that we have today. This covers kind of the bread and butter of what PolyUnity does to date. And all of these things that I'm about to show you exist and are being used in some capacity in hospitals today. A quite simple example, but impactful example, is just simply how you hang disinfecting wipes inside of a hospital. So these are brackets that were custom designed for some of the different types of wipes and sanitization equipment. And if you walk around the hospitals here today, you'll see them up on the walls. So that was very simple and solved the problem, is we got to get sanitary equipment where they're needed most, on the walls of the hospital. Laboratory services are probably the area that we have had the biggest uptick to date. This one is really interesting. This was actually developed in collaboration with a lab from New Brunswick. And this is how you process pap smear sampling and do it in a more efficient way. This is one unit, but you can imagine if you had a whole bunch of samples, we can make these as big as you wish. So the ones that we actually deliver would have about 10 patient slot samples available, and you take your sample and move it through the workflow in an efficient way so you can process your samples quicker, not get them mixed up, and decrease error. So it was back when we were still in medical school, and we were exploring the potential of 3D printing in Newfoundland and Labrador, and it caught wind to one of the local radiation oncologists that we existed. And he said, we're doing this archaic process where we're having to plaster cast patients' faces, and that effectively would get you the shape of their face. So you take the plaster off, fill that with more plaster, and then you'd end up with this, and they'd build a wax bolus. So the procedure is called a bolus production, and when you get radiation therapy, it helps to basically keep the radiation where it needs to be and doesn't burn any of the surrounding tissues. Okay, so the first way that we did this was actually printed the patient's face, and we were able to produce that, give it to them, and they would build the wax bolus over it. This has since matured and gotten a little bit more sophisticated in that we're actually now producing the end result bolus, which is made out of silicone. So this would be accustomed to your anatomy. So if you were getting radiation to an ear or a nose or something that was a little more complicated than just a flat surface, you need that level of customization in order to do the delivery of the radiation appropriately. So again, keeping with the future of 3D printing and customized medicine, one of the things that is gaining a lot of steam in the industry right now is custom casting and splinting. So again, a far cry from this very small finger splint to producing a full-scale custom cast. But this is one of the applications that is gaining a lot of popularity in the world. And what our mission is to find the highest quality, best of class services and deliver them at home. Having had ankle surgery in May, I was not allowed to weight bear on it for 2 months. scanned my limb. Our team was able to produce me an ankle and foot cast. And two of the most important things that happened there was I was able to get a shower and stay clean because it's waterproof. But also, I recently had a baby and was able to take him to the pool and have a swim for the first time. So for people who have like active lifestyles and stuff like this, it allows you to get wet and dirty and be able to clean it. So your lifestyle isn't interrupted as much. But also just for comfort and breathability. If you have an incision on your arm post-surgery, you can kind of see the wound through the mesh in the cast and observe it for healing and things like that too. So there are a lot of interesting little benefits with it when you just compare it straight to the plaster casting. And as we start to get the workflow figured out, we should be able to deliver this to patients in Newfoundland and Labrador in the near future.